Hello everyone. In this video I'm going to demonstrate or to show you the first application or first video about smart home, and even we will have a short review about the fog computing. So what is fog computing? What is cloud computing? So through this video you are going to have the glance or a short view about these two concepts. Okay, so this is Packet Tracer Activity 4.2.2.4 from the course Connecting Things from Cisco. Okay, so let's get started. So the activity is here. Here we have, as you can see, we have a smart home, and here this home is connecting to the internet through this cable here. And let's get to see what are the objectives. Here we have to explore the smart home, and the second one we are going to analyze the usage of fog computing in the smart home. In the background, so in this activity we are going to see how the smart home looks like, and of course we are going to check the applications and some tools that you already knew about. For example, the MCU. If you still don't know what is MCU, then please see the previous videos. And here you can see this is smart battery. We already used it. This is solar panel. We also used it in the one of the previous videos, and so on. Okay, so let's get into part one and then to explore the smart home, understanding the devices that comprise the smart home. Here we have commonly ISP deliver data to and video over the single coaxial cable. Here we have the ISP, and this is the coaxial splitter 0, and here we can see that these cables leave the coaxial splitters. Here the two. In the topology, which devices does the coaxial cable connected to? So this first one is cable modem 0, and the second one is the TV. One for the TV and the second one for the data. Alright, the cable modem is the interface between the ISP network and the home network. So now we don't need to talk about the TV cable. We are going to have internet, like the connection between this home and the internet is through this cable modem, right? Because there is the data here. Okay, so to which device or to which devices this cable modem is connected? It's connected to the gateway, home gateway. This is the first one, and the second one is the coaxial splitter. This is like the router in your home. So here we have the gateway. So if we can to click on it, here we have configuration. Here we have you can see there is a page here that we can access it to control the devices. You will see it in a couple of minutes. Here we have attribute. Here the page here you can of course modify. You can run it, check it, but we will not do this task now. Alright, so this was about question A and question B. So let's move down, and then the home gateway acts as a connector and a router to all internal home devices. Yes, we talked about this. It also provides a web-based interface that allows web-based interface that allows users to monitor and control various smart home devices. Okay, so there is a web page here, and through this web page we can control all the devices in this smart home. You can see there is here a fan, there is here a smart window, smart lamp, smart door, garage door, and so on. So here notice that the home devices can connect it to the home gateway through either wire and wireless. So here we have wireless devices or wire devices. So the connection through the smart home is done through two methods. The first one is wire, the second one is wireless. So to check the wireless, we can go to the option, and then we go to the preference, and then we select hide, and then we have to find here show the wireless, and you can see now we have the wireless connections, but as it's recommended that we don't need to see this because it's here is much more obvious. Alright, so here you can list all home devices connected through the gateway. You can one more time click here, preference, hide, and then this one, and you can list there we have here a door, a smart door. We have also a smart smoke sensor. We have a smoke detector, and we have a smart home. We have tablet, and we have also smart sprinkler. We have a smart water meter, and so on. Okay, so you can list what you can see. Okay, now let's move forward to step 2, which we need now to interconnect with these devices that we listed in part C. Okay, so to do this, we can go here, we can go to desktop, you can access from computer, we can access from smartphone, but according to the tutorial, we need to access through the tablet, which is connected wirelessly to the home device gateway. Okay, so let's go there, and then let's type the IP address here, which is 192.168.25.1. And then we need to enter username and the password, which is admin, and then admin again. Here we have all the devices connected. As you can see here, we have devices that can be controlled, like open or close, or we have here devices that only to monitor. For example, here there is a smoke detector. Here we have 0 because there is now no smoke in this smart home. So here there is no way to control. It's only like a meter to check the value of the smoke inside the house. Here we have a smart alarm. Here we have, for example, garage door. This one here, this one can be controlled. So when I click this one, you can see the garage door is open now. Here is closed again. Here we have also smart window, which is this one here. I can control it from here, from this application. And also we have a smart door, which is this one. Now you can see now it's a green here. So now it's open. So I can lock it. You can see now it's red again. Now it's open. Here we have a smart sprinkler, the garden. Here on, here is off. Here we have a smart water meter. There is no way to control. Here you can check only the water level. Here we have a temperature meter and so on. Coffee maker, smart fan, and smart lamp. Okay, so this is the web page that we can control the smart devices in the home. Okay, I recommend you to also play around with this. So this was step 2. Now let's move forward and let's understand what is the fog computing in the smart home. Alright, so there is a cloud computing and there is a fog computing. When we say cloud computing, that there is some cloud in the internet. So you can see there's this type of cloud here. It's resembles like cloud, but it's here represents the internet. So if you need the data to be processed in the cloud, then we call it cloud computing. But if we need the data to be processed locally, we call it fog computing. For example, here in this MCU, we have a program here written to check the level of the smoke in this house. We remember we have a smoke detector or smoke sensor to measure the value of smoke inside the house. Okay, so according to this, there is a program written there, here in Java, and as you can see there, if the smoke level is above a threshold value, which is 10, then open the door, the garage door, and to ventilate the house. If it is less than 1, or 0, then close the door because we don't have a smoke here. Now, this threshold value or this program, if it will be written in the cloud, then we call it cloud computing. But now we wrote the program in this MCU controller. So, and this is locally. So the data here is locally. And one of the advantages, is that sometimes there is a delay here and there is a smoke high level value in the house. Perhaps it's going to be a disaster and there is a high pollution in the house. So that's why it's more preferable to use a fog computing to locally make the decision when to open the doors or to ventilate and where to not ventilate according to the small value. So here the process is going to be much faster and the program is locally written here. Alright, So as you can see here, this is the smoke level value. Let's put it here, and now let's make an experiment. Here, let's start the classic car. This classic car is an old type. There will be a carbon monoxide car in the air, and then we will, according to this, the detector will check the smoke level, and when it's more than 110, then the house or the smart home is going to ventilate by opening the doors and starting the fan. Alright, let's try to do this. Again, to turn on or to turn the engine on of this classical car, you have to press Alt and then click on the car, and as you can see here now, the smoke level is increasing actually. When it's more than 10, then we are going to start to ventilate. You can see here the garage door is open, smart door is open, and the smart fan is moving, and smart window is also open to ventilate. They are still open because the smoke level is higher than expected. Okay, let's turn off the car. You will see after a while that now the smoke level is now approached or starting to become 0. Then we don't need to ventilate anymore. Then the window and the doors and the fan like closed. Alright, so one more time, this is a type of fog computing because we have the program and written in this MCU, and this locally. It's done inside our home or inside our smart home. We didn't need to send it to the cloud. Perhaps we have bad internet connection, we have no internet at all for maintenance or for some reason, and then when the carbon will be high, like this will going to be dangerous for the people live inside this smart home. Okay, hopefully it's clear. One more time: fog computing, cloud computing. Fog computing, you have your processor, you have your server, you have your application close to you, and then we send if you would like to make the application in the cloud, then we call it cloud computing. All right. So this was about step 1, what I mentioned. Now let's answer the questions. What happens to the air inside the house with the car running inside the garage? So actually starting to ventilate. What happens to the air inside the house after the MCU opens the door and the window and starts the fan? Still to ventilate, like we are going here waiting to smoke detector to realize that the smoke is low level inside the house. Okay, while still monitoring the levels, stop the classic car's engine by holding the Alt key and click on the classical car. I already did this, and that's why we saw that after the ventilating process, the smoke detector returned to 0 and the doors closed, and also the fan stopped. Here we skip this question: does the MCU close the doors and window and stop the fan? Here, of course, no, because this question is before stopping the car. Okay, so one more time we start the car. Let's do it again. And here what happened, we can see now the doors will open. As you can see, the smoke level is high. Alright, so what happens to the air inside the house after the MCU opens the door? So the air started to ventilate. Does the MCU close the doors and windows? No, because still the smoke detector or there is a pollution or there is smoke inside the house. Now let's stop the car. What happens then? We can see everything is closed or stopped, and what happens to the doors, windows and fan? They are closed. Okay, here let's see the reflection. This example shows that the decision between cloud and fog processing depends on the application. So you, as a designer, you have to decide that this application is going to be in the internet or is going to be inside the house itself. So when to open or close the tools or the things. Okay, so here in this smart home, fog computing was the best option. In this smart home example, the data generated by the smoke sensors were processed and used to make decision regarding the house air quality. In this scenario, there was no need to send out the sensor data to the cloud for processing. Okay, so cloud processing would slow down the response time, potentially putting lives in danger. Another possible problem related to the internet link: if the connection to the internet was lost, the entire system would fail, putting lives at risk. Okay, so this was about smart home, and through smart home we also should understand the fog computing and the cloud computing. What is the difference when we have to decide this application is based on the fog computing or cloud computing? Okay, that's all for this video. Thank you so much, and I'll see you in the next video. Bye.